All right, so looking at some of these examples to apply to real world situations. Penelope is starting her first job. She will earn $24,000 in her first year, and her salary will increase by 4% every year. Calculate how much Penelope will earn in her fourth year of work. Okay. Now, yes, there is a very generic and basic way to go about figuring this out. You can sit there and you can do what? I'm talking about generic way to figure out how much she earns in her fourth year. Ready? You take 24,000, you multiply it by 0.04 to get a certain amount that you would have to add to 24,000, and then take that amount, multiply by 0.4, take that, add it, and do that 4 times. Okay? That might take a little bit long if you're doing a time test. Now there is a shorter way using some formulas here. Okay? Because if you're increasing by 4% each year, this basically kind of models a geometric type of situation. Okay? Where 2,400 represents what? Base of 1, or use of 1, your first term. Okay? So if that's the case, then what would my R be? What would be that that common ratio? Say again? It will be 1.04. Why would it be 1.04 instead of 0.04? No, it wouldn't decrease it. It would be increasing by 104%. It would basically take the amount that you have to start out with, and then on top of that amount, add on the additional increase in total. If you just did it by 0.4, it would just give you just the increase, not the total after increase. Does that make sense? So, with our rate being 1.04, we can plug it into our formula, okay? Of u sub 1 times your rate. And now, in her fourth year of work, okay, that's what we're looking for. We're looking for in her fourth year of work. Are we going to plug in 4, or are we going to plug in 3, or what? What's going to be in our exponent? It's going to be 3. And this will tell us exactly how much she'll be earning in her fourth year of work instead of going through step by step and multiplying by 0.04 every time. Somebody do that. And we are talking about money here. We are talking about money. So how should you round? 2 decimal places. So the nearest hundred. Yes.
26,996.
And this is in dollars. Yes. So that's how much she's going to be making in her fourth year of work. Questions? Now, one kind of way to also kind of let you know that it's going to be 1.04 or 1.13, whatever your percent is. If it talks about an increase by, that kind of is like one of those keywords to let you know that, okay, it's 100% plus whatever percent I have that's given to me to convert to a decimal. That's going to be my rate. Okay? If it said her salary decreased by 4%, what would have been your ratio then? What would have been? Negative. Yeah. So if we're talking about a decrease here in her salary, it wouldn't be negative. What would it be?
0.04.
What would be 0.04? A decrease in her salary. Say it said decrease by 4% instead of decrease. No. You will multiply by 96%. Because if it decreased by 4%, she's not getting 100% of her salary issue. She's only getting 96% of her salary because it decreased. So instead of doing 100 plus 4% to get the increase, you would do 100 minus 4% to get the decrease. Does everybody understand that? Okay? So I'll write that down. If it said decrease by 4%, then your ratio would have been 0.96, which is basically 96% of her actual salary. Okay? Questions on that? Trying to cover two things in one. Exactly. That's how you figure out your raises. So when you start working and your boss talking about some, hey, you're gonna get a 0.25 raise, you know that's gonna be basically pennies, okay? You can figure it out. How much is minimum wage? Alright? Wait, that's the next one. Oh, yeah, question?
Why would it not be? Oh, because you don't have the full one.
Exactly. You're actually not even getting your full anymore.
How much is minimum wage?
I think it's 8. Alright, here's the next example. Alright, so for this example, a ball is dropped vertically. It reaches a height of 1.6 meters on the first bounce, and the height of each subsequent bounce is 80% of the previous bounce. It is 80% of the previous bounce. So, find the height the ball reaches on the 6th bounce. Find the sum of the first 7 terms of the sequence. So, in other words, find the total height of the ball is. Alright, so this right here should model a geometric type of a sequence. Hopefully recognize anytime it talks about a percentage, okay, you're dealing with geometry. Okay? And what's our first term?
1.6.
1.6. What's our ratio?
0.8.
0.8. This one, you don't have to do 100 minus 0.8 or anything like that, okay? Because we're not talking about a decrease or an increase. Yes, the ball is bouncing, and we know if we bounce the ball and let it roll, it's going to, start to not bounce as high. But we don't apply the whole, 100 plus the rate or 100 minus the rate here, okay? So our first term is 1.6. Our rate is 0.8. And so we can use our equation to figure out what the height will be on the 6th bounce using our general formula. Can you guys go ahead and figure that out? What the height will be on this 6th bounce?
Wow.
So, what'd you guys get?
0.524.
Because you raised it to what power? Fifth.
Yeah.
5 is coming from, remember the general formula has n minus 1 in it, so you plug 6 in, that's where the 5 comes from. So on the 6th bounce is at 0.5, I forgot, 24. And do not forget your meters, don't forget your units, okay? So there you go. That's his height on his 6th bounce. Now it says find the sum of the first 7 terms of the sequence. You guys can do that. So I'll pause you guys again, give you about a minute to find the sum if you haven't already done that. Find the sum. What'd you guys get for the sum?
I got
1.58.
1.6.
Yeah, like 4 times. Yeah, I messed up.
I got a negative. Oh, no, I didn't hear what they said.
Yes, that's more correct. The sum should have been 6.32 because you have your first term of 1.6, you have your rate of 0.8 that you raised to the what power? 7 power minus 1 all over 0.8 minus 1. Please make sure that if you type this into your calculator, guys, if you can kind of like go ahead and do whatever 0.8 minus 1 is and just put negative 0.2, it could possibly save you from making that error of forgetting to include your parentheses. But you should get 6.32.
So dumb.
So
Yes. Okay.
I put negative 0.8 instead of negative 0.2.
it's 1 minus.
That's the other formula. It could be 1 minus your rate, or you could do your rate minus 1.
It's easier to do the minus 1.
It doesn't matter for that. Like for geometric, it doesn't matter which one you do.
So you can put a test like an empire before that.
Yeah. Questions on this? Okay. I'm going to do a follow-up question to this particular problem. Does everybody have this written down? So I'm clear to write my next question. Okay. The follow-up to this is on which bounce is the height of the ball 0.25 meters. Okay? So I want you guys to figure this out. Gonna give you 2 minutes.
In general,
So we're gonna be using the same formula of 1.6 times 0.8, but this time we don't know what our exponent is, so it's gonna be n minus 1. It has to be less than 0.25. That's a reader.
just in general.
Okay? Now, the reason why I wrote this is because something like this, you know, it is in your calculator. Okay? But you want to make sure that if you don't get the right answer, you at least give the grader something to let them know that you knew what to do. This thing's didn't work out on your calculator to get the right answer. Make sense? Okay, so showing that you know that this is what you're going to end up doing, we're going to go to our calculator. We're going to go to where?
Tables.
I got to go to y equals because I got to type my equations in first, don't I?
Yeah.
How do I get rid of those equations?
Clear.
Clear.
Blur.
Okay, that's how I get completely rid of them. Okay? I'm going to type in what into y1? 1.6, 0.8 raised to the x minus 1. Now, if your calculator does not automatically go up into the exponent like mine does, it just gives you the caret. You have to put that in parentheses. Put the x minus 1 in parentheses. Yours does not automatically go up into the exponent. It's better than 6, I'm sorry. Then what do I type in y2?
Can you do it?
0.25.
0.25. You basically put one side of the inequality on the left side onto y1 and the other inequality on the right side to y2. Yes.
Does it either way work? Can you like 25 first?
Yes. It doesn't matter which curve is going to graph first.
Yeah.
Now, I just changed my calculator just today, and I changed my window to, I think, what, 30,000 was the last thing we did? So, I need to fix my window because 30,000 is not going to let me see that 0.25. What do you think I need to change my window to?
1.
I at least want to be able to see my line, so I'm just going to go ahead and change this to 1. And because I know that I cannot have a negative height or a negative number of bounces, I'm just going to go ahead and change my y min to 0 and my x min to 0. Do you have to do this? No. But I just want to see just the path of the ball. Positive bounces, positive heights. So I'm going to go to graph. The first equation that's coming, that is the path of the ball and its height of its bounces. And then this is when the height is going to be at 0.25. I'm looking for what? The intersection. So I go where?
Put that good old second trace.
Second trace. Go to
Intercept.
option 5. Option 5, which is intersect.
And you're gonna left click that baby all the way up there.
Left click it because I want to be closer to my intersection. If there were multiple intersections, I did not want the calculator to get confused on which intersection I wanted to find. Your X max? Doesn't really matter. You just need it wide enough so you can see the intersection. We went to second trace. And went down to option 5, intersect.
Why is mine like this?
But
I see yours. So, I move closer to my intersection. I do what?
enter
How many times?
3 times. There's that number.
And I see that it's going to be 9.32. Okay? But I'm talking about my number of bounces here. So is it at 9 bounces when it's less than 0.25 or is it 10 bounces? 10. Exactly.
Wait, why do you enter from not like right off?
Huh?
Like I just entered mine right off.
Well, it can be like right on the intersection or it can just be close to. You basically just need the cursor closer to the intersection that you want.
I got like
Did you click does it say intersection? Or does it say so yes? Alright. So that was again just the practice with the calculator. So again, if you ever are looking for an exponent or if you have an equation, you can always find that variable by using your calculator, making sure you adjust your window and go to second trace option what? 5. for intersect. Before you go,